Imagine that you are comfortably sitting in your living room, watching the game, when all of a sudden, the power goes off. You walk outside to see what's going on, and you realize that only every fifth house on the street has lost power. Now, according to the Nuclear Energy Institute, 1 in every 5 homes is powered by nuclear energy. However, no nuclear power plants have been built since the 3 Mile Island incident in 1979. Which means that many of our current plants are using old and outdated equipment. Now, over the summer, I had the opportunity to intern as a reactor engineer in a nuclear power plant, and I saw firsthand how these outdated and used components can cause problems. One such component is the O-ring, which is used in the control rods in the reactor. When the O-ring leaks, this can cause detrimental problems to reactor operation. However, there is a simple solution. Now, for the next couple of minutes, I will explain to you the function of the control rods in the reactor, the role that the O-ring plays in this function, and how a silver-coated C-ring can solve many of the problems in the O-ring design. So, how does nuclear power work, and how does the control rod function in this power? Nuclear power comes from obtaining fission. Fission is caused by a small neutron hitting a relatively large atom, causing it to split up, releasing more neutrons and a lot of energy. Now, this process, again, releases a lot of energy. In order to control this energy, we use control rods, which, by definition, according to Lamarche and Barada, are movable pieces of neutron-absorbing material. Here, you can see the neutron going towards the atom, and the control rod will eventually block its path and absorb it. Now, these control rods, for our intensive purposes, travel up into the reactor, for we are looking at boiling water reactors. And as they go in and out of the reactor, they experience very high temperatures, up to 500 degrees Fahrenheit. So, in order to keep them cool, cooling water goes in and out of the control rod. However, when the control rod is moving up and down the reactor, it needs to seal so that the cooling water does not leak. And that's where the O-rings come in. The O-rings, as you can see, are labeled by the yellow arrows. They prevent the cooling water from leaking out of the control rod. There are 3 O-rings, 1 large one in the center and 2 smaller ones on the outside. Now, the O-rings are Teflon-coated hollow stainless steel tubes. And depending on their size, whether they are the large ones or the smaller ones, either have 4 pinholes or 2 pinholes, respectively. Now, how do they seal? Well, according to Jack Gamble, the systems manager at the nuclear power plant, the O-ring seals by becoming energized. What happens is the pinholes, as you can see in the diagram, will fill up with high-pressure reactor water. Now, the difference in the pressure of the water and the outside pressure causes the O-ring to expand upon itself and become a seal, as you can see in the diagram. Sounds pretty simple, right? Well, there are a lot of things that could cause this from happening. Chalk River unidentified deposits, which defined by the Nuclear Regulatory Commission, are basically irradiated particles and rust that collect at the bottom of the reactor. Now, when the control rod moves up the reactor, this crud, as it is called, will fill up into the pinholes, and they will block the high-pressure reactor water from entering them, thus not allowing the O-ring to seal, thus causing the control rod to leak. Also, these O-rings are installed with heavy lifting equipment, which leaves a lot of human error. That means that if there's a slight mispositioning in the installment, that could either defect the entire O-ring or even just break the Teflon coating, and that would cause it to be less durable to the thermal cycle, which I will explain later. Now, what are the consequences of these things happening? Well, according to Declan Doran, a qualified nuclear engineer at the plant, a hot rod, as it is called, or a heated control rod, will move slower into the core than a normal control rod would. Now, this doesn't help when you need the core to shut down as fast as possible in case of an emergency. If you have all the control rods moving at one speed and one moving slower, this can be very detrimental to the plant. Also, a hot rod could double notch. That basically means that if the operator says he wants the control rod to move to this said position, Instead, the control rod will move to this position. This causes a change in the flux, which can also be detrimental to a plant operation. Also, excuse me, the rods go through a thermal cycle, as I mentioned before, between 150 and 500 degrees Fahrenheit. This means that they maneuver from 500 to 150 and then back to 500 again. Now, if an O-ring already has a leak, either due to crud or human error, then the ring will eventually expand and contract based on these varying temperatures. This could cause the leak to increase. And finally, a plant can only have so much leakage before it must shut down, according to the NRC. And if the plant reaches that leakage amount, it has to shut down. Now, as I mentioned before, about 20% of the U.S.'s electricity is provided by nuclear power. The leaks that are caused by the O-rings can prevent a plant from providing this much-needed power. However, in my research during my internship, I found that silver-coated C-rings could help solve many of the problems caused by the O-rings. These C-rings function the same way the O-rings do in the fact that they have to energize to seal. However, as you can see in the diagram, they do not close completely like the O-rings do. This allows them to not need pinholes. If you don't have pinholes, crud cannot come in to clog them, and so that problem with the crud is practically eliminated. As you can see, we have a cross-section of the C-ring which has already been energized and is completely covered and has sealed the control rod. It is now being compared to the clogged O-ring, which again causes leaks in the control rod. These C-rings are coated with silver. Silver on its own is more resistive to radiation than Teflon is. And also, according to GE, the manufacturer of these rings, the silver coating allows the C-ring to be in temperatures ranging from cryogenics to 1600 degrees Fahrenheit. Now, the dual effect of being more durable to radiation and more durable to various temperatures allows these C-rings to have a very long life, even longer than the control rods themselves. Now, I'm sure you're wondering, oh, well, what's the cost of this amazing solution? Well, the one-on-one ratio cost of the C-rings compared to the O-rings, there's not that much difference. So when you're ordering a bunch, the cost difference is pretty negligible. Now, in 2010, the first installments of C-rings will happen in 2010. And the estimated cost for this operation will be $28,000. I'm sure that sounds a lot, but when a power plant goes off, even for a day, the utility loses about $1 million. So $1 million versus $28,000, I would install those C-rings. So now we have a fairly simple solution to a problem that could eventually cause a lot of damage to a power plant. The lack of pinholes, increased durability, and negligible cost difference of the C-rings make them a practical solution to the faulty O-ring design. And by installing them, we are preventing leaks and improving the power plant's operation. Now, when a power plant goes down for only a day, a utility is first forced to turn on its coal power plants in order to meet the energy demand. By decreasing the risk of leaks in the reactor, the risk of having to shut the reactor down also decreases, and ultimately the need to turn on our coal power plants. Currently, our nation is looking into having clean energy, and nuclear power is a very safe and efficient clean energy source. However, due to recent economic events, no nuclear power plant will be built anytime soon. So it is imperative that we keep our current plants pristine. I believe that by installing these C-rings, not only will we be helping the nuclear industry, but our nation as a whole. Thank you.